All right, Im2 peeps, we're going to go over some of these problems. It's very important that you watch the video from Monday. It has a lot of new stuff in there. Rewatch it if you have to. I'm going to slightly go over some of that stuff, but it's a lot more detail in the video, especially if you're struggling with this. And I say that because the stuff we're doing here is new information. And it's not like we're in a classroom to get it done. So please watch the Monday video. We're going to take it slow and go from there. All right. So let's do number one. We want to figure out which is the following is true about the quadratic function. So what you have to remember from the video is that we have something called an a value. This is the number that's multiplying in front of the parentheses here. Okay. This is vertex form. So my a value here, even though there's not a number, it's always the number 1. So my a value is equal to 1. Okay. My h value is always in parentheses, and it's adding and subtracting to the x. Okay. But what's great about the h value, or different, is we have to switch the signs. So in the parentheses is -4, but my true h value is +4. Okay, your k value is adding and subtracting number outside of the parentheses. So the k value will never be in parentheses. So the k value is straight up. It's just +5. All right, in the video, it details what these control. When we graph these things, these control certain things. Okay, so please watch the video for further explanation. All right. So from the h and k value, we actually can get our vertex. This is why it's called vertex form. Okay, so in other words, our vertex, remember, is a point, and it is going to be our h and k value. So our vertex in this case is going to be 4, 5. Since my a value is positive, that means my parabola opens up. So it opens up. This is all from last week as far as opening up. That means my vertex, which is this point here, since it's at the bottom of the valley, this is called a minimum point. So our vertex is the minimum point. Okay, so we have to figure out what is true about this. So it says in problem A, it has a max value of y equal to 5. Well, we know this cannot be true because we actually have a minimum value of 5. Okay, so remember, this is still our x and y value. So this is what it's referencing here. What is your maximum y value? Well, all I know is I have a minimum point or a minimum y value. Okay? And it's a minimum y value of 5. All right? So this is not true. Okay? B says it has a minimum value at y equals 4. Again, my minimum value of y is 5. Okay, so again, this is not true. It has a max value at y equals 4. So again, my max y value is not 4, it's a minimum value of 5. So this is not true. And last but not least, it has a minimum value of y equals 5. And this is true. So again, this is a minimum vertex. So my y is a minimum value of 5. So D would be your answer. Again, I cannot stress this enough. Please watch the video from Monday in its entirety. Listen to it, pay attention to it, and this will get further explained. Okay? Let's go on to problem number 3. So problem number 3 here. We have our graph. We're going to graph this guy. Okay, and we're going to use the 1, 3, 5 rule. Okay, so again, this is all in the video. The 1, 3, 5 rule is all in the video that we graphed or from Monday. So we're going to use the 1, 3, 5 rule to graph. So I'll slightly explain here, but the video goes in more detail. Okay, so what I like to do is just we're going to find the vertex. Okay, so my A value, first of all, is the number here, which is going to be 1. So I'll put that in for you. Always have to have an A value. A value cannot be 0. Our H value, which is in parentheses, the number adding and subtracting, but we switch its sign, is -5. And then our K value is a number adding and subtracting, which is +1. Okay, in the video, it tells you that A controls how wide my graph gets or how narrow my graph gets. So watch the video here. Okay. H in the video is explained that it controls my graph going left or right. Okay, so this controls left or right of moving my parabola, and the K value controls up or down. Okay, so again, watch the video for further explanation on that. So let me put this controls width. Okay, so to start, I'm gonna find the vertex. So my vertex here, I'll put it up here for the room. Pretty simple. Remember, it's your H and your K value. So my H is -5 and my K value is 1. So I'm going to plot that point. -5, 1. So 1, 2, 3, 4, 5. That's -5, +1. There is my vertex. And we know that my parabola is going to be a happy face, so it should go in this direction, which makes this a minimum point again. So this is a minimum point. All right. Also, your vertex controls your axis of symmetry. So there's a line here that I'm going to draw in because my graph should be symmetrical. The left side should equal the right side. So we're going to use this axis of symmetry. So there it is. Okay. The equation, remember, for axis of symmetry, I'll just put it up here, is x equal to whatever my x value is here. So this is my AOS equation. X equals to -5. All right. So now let's use the 1, 3, 5 rule to graph, and then we'll come back and do standard form. Okay? So what the 1, 3, 5 rule says is every time I go over 1, I'm going to go up 1. So over 1, up 1. When I go over 2 or over 1 again, I'm going to go now up 3. Over again, I'm going to go up 5. Okay? So the 1, 3, 5 rule, which is explained in the video, is how much you go up as you go one movement to the right. So watch. Let's put this in a different color. So as I go over 1 from my vertex, well, let me back up. Again, this is controlled by your A value. So your 1, 3, 5 actually gets multiplied by your A value. So my A value is 1. So So if you look, if I multiply the a value here, does it really change the 1, 3, 5? So 1 times 1 is still 1. 1 times 3 is still 3. 1 times 5 is still 5. Okay? So the a value did not change my 1, 3, 5 rule. All right? So let's show you how this works. As I go over 1, I'm going to go up 1. And I'll put a dot there. Okay? So now, let's go here. As I go over 1 again, so from here going over 1, I have to go up 3 now. So 1, 2, 3. Okay, so again, over 1 for the second time, up 3. That's the 3 rule. And then lastly, I'm going to go over 1 again. And that means when we go over 1 for the third time, we're going up 5. So over 1, up 5. 1, 2, 3, 4, 5. And that is my final dot. And if you look, I have a nice parabola which I'm going to put in black. Okay, and then we can use the axis of symmetry, this line, to copy these dots over. So let's copy the purple over. So from the axis of symmetry over 1 to the right, so I'm going to go over 1 to the left. So we're just copying using the red axis of symmetry as a mirror. So over 2, so mirror that, and then the green dot. Over 2, 1, 2. Okay, and once you mirror it, you have your parabola, your entire parabola. Okay, that's how you use the 1, 3, 5 rule. So again, we went over 1, up 1, over 1 again, up 3, over 1 again, up 5. The 1, 3, 5 rule. And this works for every single parabola. This is the pattern. All right, let's go to standard form really quick. So to do standard form, we're going to take vertex form and just multiply this out. So in other words, we're going to take, instead of f of x, I like to put y equals x plus 5 squared plus 1, which is really x plus 5, x plus 5 plus 1, and then we're going to multiply this out. X times x, x squared, x times 5 plus 5x, and then again 5 times x is another 5x. 5 times 5 is 25. And now we can bring in the positive 1, combine like terms, so y is going to equal to x squared plus 10x plus 26. Okay? So now we could actually use standard form to find the y-intercept. Okay? And the y-intercept is always x equals 0. So in other words, you're going to take your x value, plug it in here. So 0 squared is 0. 10 times 0 is 0. And then we have positive 26. So 0 plus 26, we have y equal to 26. Therefore, this is my y-intercept. Okay? So it's going to be 0, 26. Again, to find the y-intercept, it's better if you have it in standard form and you plug in 0 for x. All right, so that is number 3. All right, so with less explanation, let's go ahead and do number 5. So number 5, again, I'm going to put my a value. A value is -2. H value is -1. K value is 8. Okay, so again, in the video, it explains what a value does. Okay, in this case, the a value, because it's negative, means I have opening down, and since the number, ignoring the sign, but the number 2 is bigger than 1, it becomes a skinnier graph, or more narrow. Okay, so the bigger this number without the sign, the skinnier the graph gets. The smaller this number, so think of a fraction, the fatter or wider the graph gets. Okay, so our h value is -1. That means we're gonna shift to the left, because the h controls left and right movement. Since it's -1, we are shifting backwards. Remember, your true h value is always the opposite sign here. So we're going to go backwards here. And then k controls up and down. Since it's +8, that means we are shifting up 8. Okay? And all this shift can be handled by the vertex. So again, my vertex is going to be our h and k. So my h value is -1. My k value is 8. So let's plot this point. -1 up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. There it is. And this is, again, because my a value is negative, I know I have a vertex that is a maximum point. So we have a max point. Okay. So let's try our 1, 3, 5 rule really quick. Okay, to graph the rest. So we have our 1, 3, 5 rule. Remember, your 1, 3, 5 rule is affected by your a value. So I'm going to multiply my 1, 3, 5 by -2 and get my true 1, 3, 5 rule. So -2 times 1, that's -2. -2 times 3, -6. -2 times 5, -10. So what this means is I go over 1, I go -2. So over 1, which means down 2. Over 1 again, down 6. Over 1 again, down 10. So let's watch how this gets done. Okay. So over 1, which means I have to go down 2 because it's negative. So 1, 2, put a dot. So now we go to the next one. Over 1 again, from here, over 1. And now we use our rule. Now the rule says we're going to go down 6. 1, 2, 3, 4, 5, 6. Put our dot there. All right, and then we go over 1 again, which means we are going to go -10 or down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, almost forgot. Our axis of symmetry always goes through our vertex. So here's our axis of symmetry. We need that to plot the other side. Okay, so remember, axis of symmetry is x equal whatever x vertex is. -1, that's our AOS. And now let's copy our points. So copy this one, the purple goes here, the blue over 2, over 2, and then the green gets copied across the axis of symmetry. So that's 1, 2, 3 over, 1, 2, 3 over. Okay, and now you have this beautiful graph. Okay, and that's our parabola. All right, hopefully this 1, 3, 5 rule is helping you graph. It's a quick way of doing it. So let's go ahead and put this in standard form. So we're going to take our function, put it y equals -2 x plus 1 squared plus 8. X plus 1 squared is x plus 1 times x plus 1. Plus 8, don't forget your 2 here. So I'd like to multiply this stuff first. So I'm going to distribute x times x. X squared. X times 1, that's plus x. And then we do this again. Plus x for here, 1 times x, and then plus 1. So that gives me 2 times x plus x squared plus 2x plus 1 plus 8. Distribute the 2 now, so 2 times x squared, 2 times 2x, 2 times 1. So the 2 gets multiplied in. 2x squared plus 4x plus 2 plus 8. And then we combine like terms. So y is equal to 2x squared plus 4x plus 10. So this is standard form, and then we're going to use standard form to solve for the y-intercept. Remember, y-intercept is going to be an x value of 0, and then we got to find our y value. So we're going to plug in 0 for all these x's. So y is equal to 2 times 0 squared plus 4 times 0 plus 10. So this turns into all this here. If you do this math, it's 0. This is all plus 0 plus 10. And you get y equal to 10, which is now your y-intercept. So 0, 10 is their y-intercept. And if you look, it's right here. Sorry guys, I just made a mistake here. If you notice, I forgot to put a -2 here. So that's going to change everything. So let's multiply that in. Okay, so that's going to be negative 2x squared minus 4x minus 2 plus 8. And that's y equal to negative 2x squared minus 4x plus 6. Okay, so this is our standard form, and now we got to use that to find our y-intercept. So same process, just different equation, my mistake. So it's 0 for my x, and then we're trying to find our y. So we're going to plug in 0 for the x's, so negative 2 times 0 squared minus 4 times 0 plus 6. Y equals, this again is 0 minus 0 plus 6. Y is equal to 6. And that is your y-intercept. Okay, and I noticed my mistake because my y-intercept is here and it should be 6. So it's 1, 2, 3, 4, 5, 6, and there it is. All right, it's a longer video, but hopefully all this stuff helps out. Thanks.